Hello, and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of equations and inequalities. This is 7.11a Readiness Practice, the intermediate version. If you are interested in exploring the 7.11a Readiness Practice for the proficient or advanced versions, or the Readiness Practice resource aligned with any other standard, you can find those by using the link in the video description. So we have a word problem here. We need to write and solve a one-variable two-step equation. All right, so Lynn bought a book for $8.03. Okay, so our book is going to be $8. And then we've got pens. So I'm kind of going to draw it like that. We've got 3 pens, and we don't know how much they cost, but the whole thing equals $14. All right, so we need to write and solve a one variable two-step equation here. So let's do this. Let's just represent the pen as P, okay? And we don't want to say 8 plus p equals 14 because there's not just one pen. There's going to be 3 pens. So here is our one variable two-step equation. First, let's put a box around this because I just took the numbers that are given to me, 8 and 14, and those are just going to be constants. And then the variable I had to assign, I'm going to make my p as pen, and there's 3 of them, so it's going to be 3 times p. Now let's solve it. Well, what we need to do is we need to use the properties of equality. So if we subtract 8 from both sides, what that's going to get us is that's going to get us 3p equals 14 minus 8 is 6. Now we need to divide both sides by 3 because that's the inverse of the multiplication, because 3 times p can be negated if we divide both sides by 3. And then that's just going to leave us with p equals 2. All right, and so let's put a box around that. And then we'll go ahead and just put it back into the sentence here. And we'll say each pen cost, let's put the dollar sign back on because that's our unit, $2. So that is our first equation. For number 2, we actually have a picture here. We've got some algebra tiles, and we need to go ahead and write this equation. And then let's find what value of x makes it true. All right, so the long rectangles are going to be x's. So let's make that x, 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 and then these are ones, these little dark squares. All right, so really what I'm looking at here is x plus x plus x plus 1 plus 1 equals, and then I've got a whole bunch of ones, right? So let's just simplify. How many x's do I have? I've got 3 x's. How many ones do I have? I've got 2. And then how many x's do I have? Or ones do I have? 3, 6, 9, 12. All right, so this is my equation. Then let's go ahead and solve. Let's use our properties of equality. I've got a plus 2. So I want to isolate this variable. I want to get the x by itself. So let's peel off the constants. If I've got a plus 2, then what I need to do is I need to subtract 2 from both sides. That's going to get a plus 2 minus 2. That just leaves me with 3x on this side. 12 minus 2 gets me a 10. Now I need to divide both sides by 3 because it's 3 times x. So the inverse of that is going to be divided by x. So x equals 10 thirds. We can write it as 10 thirds. We can write it as 3 and 1/3. Both would be correct. Probably we're not going to put it into a decimal form. But let's put it like this. 3 and 1/3. Most likely just leave it in that 10 thirds. That's the simplest and cleanest version. If we plug that back in, we would get the answer there. Now, we've got a third problem, and it's another word problem. So we have a submarine. It's at a depth of 200 feet. All right, so this is my submarine here. And it is at minus 500 feet. All right, so right here we've got a 500 feet, so it's 500 feet below the surface. and it's going to increase at a rate of 25 feet per minute, and it cannot go above this 150 feet. So I'm going to put another red line right here. I'm going to say that's as far as they can go up is 150 feet. All right, so how do we represent that in an inequality? And this one is going to be an inequality because we're not equaling anything. We're going to use greater than or equal to, less than or equal to. Well, let's see if we can write this situation. What's our starting? Our starting is negative 500. So we're just going to start like that. And then what is it doing? It's moving up. So let's get our constant rate. The constant rate of 25 feet per minute, right? So we're looking for that rate right there. And they already tell us that we want to have t as our variable. So 25t. All right, so negative 500 is the starting spot. It's increasing at 25 feet per minute, and it needs to stay below 150. So all of this needs to be less than, and we're going to use that negative right there, less than negative 150. Now, it says it must stay below 150. It's not saying that it can be equal to 150. So that's why we're going to use less than rather than less than or equal to. Now, once we get here, what we're going to do is we are going to treat it like an equation. We're going to use properties of equality. So if I have a minus 500 or a negative 500, however you want to look at it, we need to think of the opposite of that as a plus 500 or positive 500. So let's add 500 to both sides. So that's going to get me just 25t. And I've got a negative 500 plus positive 500, or negative 150 plus a positive 500, or think of it 500 minus 150. Either way, you're going to get 350. Now, we're going to use the other property of equality, divide both sides with 25. Since it's 25 times t, the inverse is going to be divided by. And let's see, 4 25s make 100, so I've got 4, 8, 12 gets me 300. I'm going to end up with 14 because I need an extra 2 to get up to 50. So t is going to be less than 14. All right, so that's simplifying that inequality. So we need to explain what that means in the context of the problem. All right, so we can say the sub can safely, right? We have to stay underneath that safety zone of 150 feet, ascend for less than, and then let's go ahead and put our solution in there, 14 minutes. As long as we're staying less than 14 minutes, the sub is safe. All right, if you are interested in exploring the 7.11a readiness practice for the proficient or advanced version, or the readiness practice resource line with any other standard, you can find those by using the link in the video description.